Okay, for this bell ringer, you have to use the graph, and you have to answer number 1, A, B, C, and D. I took a simplified version of yesterday's notes, and we're going to talk to you about what you need to do in order to graph these. So describe how the following can be obtained from f of x. So number 1, this is something you have to kind of keep in mind. A -2 at the end is a trailer, so it's going to make it move down. So therefore it's down 2. For 1b, the -2 is affected inside with the x. So when it's inside, remember it goes opposite, because if you were to solve x minus 2 and set it equal to 0, the answer would be x equals 2. So it actually moves right 2. F of negative x, again, you're affecting the x value. There's a negative. It's the opposite of x. So think about on a graph. If you were taking a value of x and then you did the opposite, you'd actually be folding it over the y-axis. So it's a reflection over the y-axis. Part D, f of 1/2 x. Again, you're affecting the x value. Remember, this is counterintuitive. 1/2 times x is actually not going to shrink it. It's actually going to stretch it. So we would say there's a horizontal stretch. So essentially, you would multiply the x values by 2. Number 2, on the graph above, sketch f of 2x. So my suggestion for this is take the endpoints. You can kind of see the red dots. Make the chart like the video was talking about. These key points are -9, 4, -5, 4, 0, 2, and 5, 2. And change the t-chart and say to yourself, f of 2x, you're affecting the x. But what are you really doing? You're dividing all the x's by 2. So you're going to take 1/2 times x. The y values, there's nothing that's affecting the y values. So all you have to do is multiply -9 by 1/2. That's -4.5. Multiply -5 times 1/2. That's -2.5. Multiply 0 by 1/2 is 0. And multiply 5 by 1/2, that's 2.5. Now just plot those points. And then once you've plotted those points, just make the same shape . And that's your final answer. Number 3, state the domain for f of x. So this is the original. This is the original graph. Okay, so if we look at the original graph, the values on the left, if we go back up here, the values on the left all the way to the values on the right for x is the domain. So -9 to 5. For number 4, state the range for f of x. The range is the y values. The lowest y value is +2. The highest y value is 4. Every other value is included. The other thing I want to talk to you today is even versus odd functions. Even versus odd functions. The first thing you want to think about is an even function has symmetry over the y-axis. So for example, a parabola has symmetry over the y-axis. What does that mean? If I fold the graph over the y-axis, it'll lay on top of each other. However, an odd function has symmetry over the origin. So for instance, a cubic. If I fold the cubic over the origin, over 0, 0, it'll lay on top of each other. Be very careful. Some functions are neither. So a neither would be a graph that has no symmetry. Over the y-axis or origin. So for example, if I have y equals x squared plus 2x, y equals x minus 3 squared, y equals x cubed plus 4x squared minus 2x plus 1. Students often think that an even and odd function is determined by the degree. For instance, the first problem, the degree is 2. But it is not a parabola that has symmetry over the y-axis. The second problem, symmetry with 2. That graph, probably the easiest one to understand, has a vertex at 3, would look like kind of a concave up parabola. But you can tell, if I fold it over the y-axis, it doesn't have any symmetry. So the fold line for symmetry actually happens to be the line x equals 3. That's called the axis of symmetry. But this is not an even function. It's just nothing. So be careful. Degree does not mean even and odd. That's completely different. It's all about symmetry. So we have some tests for symmetry. For even functions, we have to make sure that f of x is equal to f of negative x. And for odd functions, what we have to make sure of is that f of negative x is equal to the opposite of f of x. And we'll explain that in a moment. So we're going to go down and we're going to show you some proofs. So the first example, f of x equals x to the fifth plus x. Now, the degree is helpful in some regards. We know it's a fifth degree polynomial. So right off the bat, we know it can't be an even function because that's one thing you can eliminate. It can't be an even function. So it's either an odd function or it's neither. So the question is, we have to take f of negative x, you'll notice that was in both problems, and plug it in. So when we plug it in algebraically, we want to see if we get the same thing that f of x yields. We want to see if we get x to the fifth plus x. So we get negative x to the fifth minus x. Well, what we'll notice is we don't get the same thing, but we get the opposite. These guys here are opposites. Well, if you look at your definition of an odd function, that's true, because f of x, when you take a negative and plug it in, you get the opposite of it. And that's what that needs, that definition. Let's try another example. Example 2. G of x equals 1 minus x to the fourth. Now again, the degree is 4. So we definitely know it cannot be an odd function. It's either even or neither. So if we take negative x and plug it in, let's see what we get. We get 1 minus x to the fourth. Hey, we got the same thing. We got the same thing. That tells us it's even because remember, f of negative x was equal to f of x. So both the left and the right side were equal. So the key is take negative x and plug it in. If you get the opposite out, it's an odd function. If you get the same thing out, it's an even function. Third example to show you all points. H of x. 2x minus x squared. Again, take negative x and plug it in. Be careful with your algebra. Order of operations is very important here. Negative 2x, I don't do the negative negative. I have to do inside parentheses. A negative squared is a positive. So I actually get x squared. Now when I look at this, this is neither. At first you might think they're opposites. But if you take a negative and you factor it out of this, you don't get what you started with. You get a plus x squared, not a minus x squared. So this is a case where it's neither. I hope you enjoyed the notes. Good luck on all your homework today.